These are the frequently asked questions for pre-calculus for section 4-7, day 3. I'm going to start with number 52, and it says in exercises 47 to 52, find an algebraic expression equivalent to the given expression. Hint, form a right triangle as done in example 5. So what we want to do here is think about the fact that when you deal with parentheses in math, the order of operations tells us we have to deal with the innermost parentheses first. So you'll notice that I rewrote arc cosine as inverse cosine. Sometimes just a little notation hint helps people out a lot. So that means I want to figure out an angle, theta, that would have an inverse cosine of 3x. So I want to make sure I get the sides labeled correctly to get that 3x. And cosine is adjacent over hypotenuse, so that must mean that my 3x is adjacent, and my 1 would be my hypotenuse, because we always put a 1 underneath it if we need to see a fraction. Well, now I have some work to do, because once I have the inside portion down, because right now I'm dealing with cosine of angle theta, I have found an angle that will be useful as I keep moving forward, and now I want the sine of that angle. So I want to find the sine, which means I need opposite over hypotenuse, and I don't have opposite yet. So I start thinking, I'm going to call that t. Is there a way for me to figure out what t is? And yes, it's called the Pythagorean theorem. So 3x squared plus t squared will equal 1 squared, because we have the square of each one of the sides. The sum of those two added together has to equal the square of the hypotenuse. So this will be 9x squared plus t squared equals 1, and we just keep solving for t. So we'd subtract 9x squared from both sides, and then we would take the square root. And again, we are only interested in the positive square root, because this is a side of a triangle. All right, so now we're set. We have the 3 sides, and we are supposed to figure out the sine of this very angle right here. And that would be opposite over hypotenuse, which is the square root of 1 minus 9x squared, over 1, which is, of course, just the square root of 1 minus 9x squared. So that was a good example. We did several of these in class. I think we had 6 where we were working with cosines and inverse sines and all kinds of great stuff to get those worked out. Number 53 says, a viewing angle. You are standing in an art museum viewing a picture. The bottom of the picture is 2 feet above your eye level, and the picture is 12 feet tall. Wow. There it is. There's the picture. It says angle theta is formed by the lines of vision to the bottom and the top of the picture. And we see some information there about how we can figure out what theta is. So for A, what it says is we are supposed to show that the inverse tangent of 14 over x minus the inverse tangent of 2 over x will give us theta. Well, it absolutely will. We'll go ahead, and I'm just going to pick a different label for this angle, and we can talk about what's going on. I'm going to say that the entire angle here is angle A, and I'm going to put a little alpha symbol in this teeny little angle back here. So what we know is, if we take the big triangle, and most of it is green, and we subtract the little triangle, then the difference between those two will end up being theta right there. So we would have the tangent of angle A equals 14 over x, and that's because that would be opposite over adjacent. And then the tangent of angle beta, which is the little one, would equal 2 over x. All right? So far, so good. Now, we want theta. And how we get that is by taking the tangent of angle A and subtracting the tangent of angle alpha. And then what we would do is we would continue on and say, hey, let's just substitute into this thing. So theta equals, well, the tangent of angle A, the inverse tangent of 14 over x, minus the inverse tangent of 2 over x. Would give us that information that we needed, because we need the large angle, angle A, minus, and this was alpha, I might have said beta earlier, our alpha. And once we subtract that, then we'll have what we need, which is angle theta. And that is exactly what you see in A right here. So those inverse tangents are how we're going to figure out what those angles are. And that's how we would set that up. B says, let's go ahead and graph it in a window from 0 to 25 by 0 to 55 viewing window using the degree mode. And I'm going to go ahead and stop the play here and get the calculator up. Let me show you what you have to punch in with this one to get it. This might have been the issue. We really need double sets of parentheses for this in order to get the calculator to understand that we want the inverse tangent of 14 over x minus the inverse tangent of 2 over x. So you really do need double parentheses. And the window, they already told you what to do there. I'm sure that wasn't an issue. But if you hit graph, there we go. And what we want is we want it to see the maximum. So second trace, number 4, the maximum. And it might take Blinky a little while here to get into position. That's quite a hill Blinky has to climb, because we need Blinky to come down on the other side a little bit. Doesn't have to be an enormous amount, but we just need to see that Blinky is going to come back down. Oh, and the button stuck. That's what happens with my board, smart board calculator every once in a while. The buttons stick. Oh, good. Okay, we're on the left-hand side. I'm going to quick hit enter before anything else happens. All right, now I need to make sure that Blinky comes down on the right-hand side. And again, hopefully my button isn't going to stick there. But we already see that Blinky is starting to come down. Enter. Enter through yes. And there it is. So for B, they wanted us to see that we've got our max there of 5.292. And we have a y value of 48.590390378. So it says, use your grapher to show that the maximum value of theta occurs approximately 5.3 feet from the picture. Well, approximately 5.3 feet. I mean, we saw it. That's what they wanted us to see, is that that was going to happen. And then for C, how far to the nearest foot are you standing from the wall if theta is 35? So if theta is 35, we think about, well, that's going to set up all of this here. So this is going to be 35 degrees. Well, let's just use y sub 1 and y sub 2 and let's see where it happens. So down here we want 35 degrees. And we want a graph. We can see we're going to have two answers. So second trace, let's put Blinky to work, number 5. And I want Blinky to be just over here to the left a little ways so that the calculator knows that the left side intersection is what I'm really trying to find. And again, I'm going to hope that my left button doesn't stick here. All right, so enter, enter, enter. And Blinky says at about 1.829, we're at 35. And now we will wait for Blinky to get into position for the other intersection. And hopefully the button will not stick. All right, so if we're over in that region, Blinky will know, hey, that's the one we want. Hit enter 3 times. And that one is at 15 point, let's see, what does that say? 309 approximately. So it said, how far to the nearest foot are you standing from the wall of theta equals 35? So this would be approximately 2 feet, and this would be approximately 15 feet. So more where we get the right math, and then we have to make sure that we are rounding to the correct decimal place. That's a big part of math is being able to read instructions about what to do. 6D says we need the inverse sign if we have the sine of pi. So let's see what happens here. Innermost parentheses first. We need to know what the sine of pi is. Well, this is pi. The coordinates of this point are -1, 0. So this is 0. And then we want the inverse sine of 0, which means we want to know what angle will give us 0 for sine. Well, that's this one over here, because it's always cosine and then sine. And this is going to be 0 degrees or 0 radians. And that's C. So this is testing our knowledge about quadrantal angles, about where things end up with quadrantals. Then number 66 says express each of the following functions as an algebraic expression involving trig functions. So A. And let's take a peek at A cosine when the inverse sine is 2x. Okay. Well, let's get a drawing going here. Here's our triangle, and we know that this angle has a sine that is 2x. Well, that's opposite over hypotenuse, so this will be 2x over 1. And obviously, to find cosine, I need to know what that other side is. So again, I'm just going to label that side t, and t squared plus 2x, the quantity squared, equals 1 squared. So t squared plus 4x squared equals 1 squared, which is 1. T squared equals the square root of 1 minus 4x squared. We'd subtract the 4x squared from both sides and then take the square root. And now I'll take that off because that's just t. So this is t, and it is the square root of 1 minus 4x squared. And now they ask us for the cosine. Cosine is adjacent over hypotenuse. This is adjacent. This is hypotenuse. And I start V. You see, this one has a little trick to it, because once we figure out what the secant is, we're going to have to square that. But we really do this the same way that we do A. And that is, we have to set up an angle so that it has a tangent of x. And tangent is opposite over adjacent, so we would want that to be x over 1. And then we do the Pythagorean theorem. I'll call that one t. So x squared plus 1 squared equals t squared. X squared plus 1 equals t squared. The square root of x squared plus 1 equals t. And now we need the secant, and then we have to square it. So secant, if we flip cosine, which is adjacent over hypotenuse, we get hypotenuse over adjacent. So hypotenuse over adjacent, our secant is going to equal the square root of x squared plus 1. But we are supposed to square that answer. So the square root of x squared plus 1 squared gives us x squared plus 1 for our answer. So again, we have to keep track of those little things, even if it's, squareds, a negative in front, whatever it may be, because I see a negative in D. C, we need an angle that would have a cosine of the square root of x. Cosine is adjacent over hypotenuse, so this would be the square root of x over 1. And then we need to get the sine of that. Well, we need opposite. An opposite is missing, so we're going to have to use the Pythagorean theorem again. I'll call that one t. Square root of x squared plus t squared equals 1 squared. X plus t squared equals 1. T squared equals 1 minus x. So t equals the square root of 1 minus x. Alright, so we have that, and now we need the sine. And again, sine is, here's our angle that we're looking at, theta. Sine is opposite over hypotenuse, so our answer is going to be the square root of 1 minus x. Alright, D looks interesting. Let's take a peek at D. D wants us to have a cotangent that will come out to be x. Cotangent is going to be, well, we flip opposite over adjacent. So adjacent over opposite. So it would be x over 1, adjacent over opposite for a little angle theta here. And then we could just, quickly use the Pythagorean theorem and say x squared plus 1 squared equals c squared. X, I've been using t, it doesn't make any difference, but here's our c. So x squared plus 1 equals c squared, and then square root that little bugger, and we have it. And then we want to see what they want us to say this is. And we've got this part taken care of, so we work to the outside parentheses and say, all right, now we're supposed to get cosecant. We're supposed to square it, and then we're supposed to put a negative in front, because remember, we've got to follow the order of operations. And this has a power of 2 just for cosecant. There's no parentheses there, so we're going to have to take our cosecant, square it, and then slap a negative in front of it, because that negative is really multiplication. So cosecant is what you get when you flip sign. So it's going to be hypotenuse over opposite. Good news. That is the square root of x squared plus 1. Well, we're going to have to square that and slap a negative in front. Well, when you square a square root, those are inverses of each other. So we get negative of x squared plus 1. And then we distribute that negative, and we get negative x squared minus 1. So that one probably a little tricky. If you didn't follow the order of operations, you're really going to be in trouble there. E says we need an angle such that the secant is x squared. Well, that's going to be hypotenuse over adjacent, so that'll be x squared over 1. And I will continue to use a little t over here. So 1 squared plus t squared equals x squared squared. Yeah, we have to be careful with that in this one. So this will be 1 plus t squared equals x to the 4th. T squared equals x to the 4th minus 1. And then we will need to take the square root of that in order to get t. So that is the square root of x to the 4th minus 1. Now let's go back, because those were the innermost parentheses. That was the setup. And for E, it says, okay, once we've got that, now let's find the tangent. So here's our little angle. Tangent is opposite over adjacent. So opposite over adjacent is going to be the square root of x to the 4th minus 1. Whew, talk about a problem within the problem there. All right, now, number 68, advanced decomposition. Decompose each of the following algebraic functions by writing it as a trig function of an arc-trig function. Okay, trig function of an arc-trig function. Well, let's figure out what we need to do then. As I'm thinking about my triangle, I'm trying to figure out whether or not that square root of 1 minus x squared is going to be a hypotenuse or not. And I realize there's subtraction in there. So that's not a hypotenuse. That's one of the sides. So I tried to think, well, what does that mean? So we had something squared plus this squared equals the hypotenuse squared. Okay, well, how can I get all of this to work out like it's supposed to? Well, if this is 1 and this is x, let's try it and see what happens. If we have x squared plus the square root of 1 minus x squared squared, does that equal 1 squared? Well, this would be x squared plus 1 minus x squared equals 1, and the x squareds cancel out. So it does verify that what we were doing before was the right process. And so now I have this set up, and I just need to figure out a way to get them to do 1 minus x squared. Now I take a look at this problem, and I think, you know what? Square root of 1 minus x squared, that's going to be, I could do it really well for sine, because that would be opposite and hypotenuse. So I want to use something else to start with, and then decompose this. So maybe cosine. So we'll say, all right, the inverse cosine of adjacent over hypotenuse, x. And then, once you have that, take the inverse, not the inverse, take the sine of that. Because what we want is the square root of 1 minus x squared. Now let's see if it works. If they put x here and a 1 here, they're definitely going to get the square root of 1 minus x squared for this side. So they'll have the triangle all set up. And now if they find the sine, that's going to be opposite over hypotenuse, and that will give 1 minus x squared. So that's exactly what we wanted to happen. All right, let's take a look. I'm going to keep that one up here because sometimes having one done can help you figure out exactly what's going on with the others. So for B, we need our triangle to have an x and a square root of 1 plus x squared. Ooh, that's a giveaway. Because if it's the square root of 1 plus x squared, they were adding the two sides together. And then I just need to figure out where to put the x and where to put the 1, because those are the pieces that make that up. So again, I start thinking in advance, how am I going to get x over 1 plus x squared? Well, that's going to be, for this angle, adjacent over hypotenuse. So that's cosine. So that's where I want to end. I want to end with cosine. So how do I get them to start this? Well, with this one, I kind of like cotangent, because we could say adjacent over opposite. And it's not very often you're going to hear me using something that's not one of the primary trig functions, but I like the fact that that's just going to give me x. So that would definitely be one way to make that happen. Take the cosine and then starting with that cotangent inverse of x. Again, it all goes with the order of operations where this has to be the setup. That gives you the triangle. And then once you take the cosine, you have what you need for an answer. So let's look at this one. If it's x, here's x, cotangent. So this one is adjacent over opposite. If we did x squared plus 1 squared equals c squared, we would get the square root of 1 plus x squared. And then we're finding the cosine. We set up the triangle, finding the cosine. Adjacent over hypotenuse, square root of 1, x plus x over square root of 1 plus x squared. Apparently that's hard for me to spit out today. All right, so now I'm looking at C, and I'm thinking that is just slightly different. So again, try to leave some of that up here. I'm going to have to write a little smaller. So the difference being that now we have an x and we have a square root of 1 minus x squared. So that has to be one of our sides. And I know that because we'd have to subtract, and to subtract you'd have to be finding one of the sides. And then we have that x, and that would have to be one of the sides to square it, and we need a 1. So I think again, is this going to work? Well, the square root of 1 minus x squared, you square that, and you get 1 minus x squared. You square x squared, you get plus x squared. You add those together, you get 1. So it works in the Pythagorean theorem. And now, I'm going to think backwards. In the end, I want x over the square root of 1 minus x squared. So for my triangle, that's going to be opposite over adjacent. That's going to be tangent. Now, I think, how am I going to get them to get this triangle all set up? And I'd rather not write anything really nasty if I don't have to. I mean, look at the last example I just did. I was able to use x. So let's see. Maybe I could get away with that here as well. So I look at it and think x over 1. That's opposite over hypotenuse. That's sine. So if I tell them I want the inverse sine to be x, then they'll have to work their way backwards and get all of that. So that would be a good one to do. The tangent of the inverse sine of x. Again, you can check it forwards and say, okay, I need the sine to be x, opposite over hypotenuse. If we did the Pythagorean theorem to figure out what this side is, we would get 1 minus the x squared, the square root of all of that. And then tangent, well, tangent is going to be opposite over adjacent. So opposite x over the square root of 1 minus x squared. And that is exactly what they wanted us to find. Now, I want you to remember, you're going to see a lot of answers may vary on the answers on this one, because there are, obviously you could switch around the two sides and it's not going to make any difference to any of the math that's going on here. And all kinds of different setups with which trig functions you want to use. So yours may very well have worked. You just have to double check it and make sure that things are going okay.